Hello and welcome class. So we were studying chapter number 9 of NCRT class 9 and the name of this chapter is gravitation, and in last class we have completed the topic universal law of gravitation. In today's class we are going to start a new topic named free fall. Okay. Now what is free fall? Let's try to understand the meaning of free fall by performing some activity. And activity is activity 9.2. Take a stone. Okay. Take a stone, throw it upwards. Okay. You have a stone or a ball and you have thrown it upwards at certain height. It reaches a certain height. And what will be that height? That you will reach that height where velocity will become zero, and this object will change its direction and start falling towards Earth. So, here at the maximum height, the velocity was zero, and the object is started falling towards the Earth. Okay, there is no force, there is only one force, that is gravitational force. So, this ball is only attracted by the gravitational force. Whenever any object fall towards the earth under the influence of gravitational force and no other force, then that object is said to be free falling. Any object, for in this case you have thrown the ball upward, so you have provided a force through your hand. Okay, that ball reaches a certain height, and its maximum height will be that point where final velocity will become zero. Then that object start falling towards the earth under the influence of only one force, which is gravitational force. So this object will doing free fall. Any object which falls towards the earth under the influence of only gravitational force, then that object is said to be in free fall. Is there any change in velocity of falling object? This object, this ball is falling towards the earth. Does it has change in velocity? Its direction is constant, which is towards the earth. But do you think that its velocity is changing? Direction is fixed. No change in the direction. No change in the direction. Question is there any change in the velocity of falling object? So as we know that this object is falling under the influence of the gravitational force, so there is a force associated with it, and force is equal to mass into acceleration. And gravitational force, when distance is decreasing, the value of gravitational force is continuously increasing. Okay, so the value of gravitational force is increasing. It means this object acceleration is also increasing. And if acceleration is increasing, it means its velocity also increases. Although there is no change in direction, but gravitational force is accelerating this object, it means its velocity is changing. Its velocity is increasing, and its velocity will reach maximum when this object is about to reach earth or the surface of the earth. Due to the earth's attraction, there will be a change in the magnitude of velocity. Clear, class? Any change in the velocity involves acceleration. As I told you, this is our ball and this is our earth. Okay. Gravitational force is pulling this object towards Earth. And we know that force is mass into acceleration. As this object is falling towards the Earth, the distance between this object and Earth is decreasing. And we know that force is G m1 m2 divided by r square. If distance decrease, force increase, and if force will increase, then acceleration will increase. Clear, class? Acceleration will increase, then there is a change in velocity. So this acceleration is due to Earth's gravitation force. This acceleration is due to Earth's gravitational force. Therefore, this acceleration, the acceleration of a free falling object, is known as acceleration due to gravitational force or acceleration due to gravity. And this acceleration is denoted by a new symbol g. Okay, g is acceleration due to gravity. Okay, class? So I hope acceleration due to gravity is clear. When an object is doing free fall under the influence of the gravitational force, then that object has a acceleration. And that acceleration is because of gravity. So we call that acceleration as acceleration due to gravity. And that acceleration has a symbol small g. Okay. And because small g is just the acceleration, so it also has the SI unit or standard unit meter per second square. Clear? We know from the second law of motion that force is the product of mass and acceleration. Okay. Let the mass of a stone, uh, let the mass of that stone or the ball which we are throwing upward, then it comes to rest and then free fall is m. Okay. Let's suppose the mass of that stone or that ball is m. After reaching any height, that object of mass m will start doing free fall under the influence of the gravitational force, and it has the gravitational acceleration of small g. Then the force will become mg. Is it clear, class? I hope it is clear because we know that force is mass into acceleration, and in this case the acceleration is gravitational acceleration, so force will become m into g. Now we know that force is g capital M small m divided by d square. Okay, so from mass of the object is cancelled, capital M is mass of the earth. So the value of small g depends on the mass of the earth and independent of the mass of the object. It means the value of gravitational force, which is gravitational acceleration, does not depend on the mass of the object. It only depends on the mass of the earth, independent of mass of the object. Okay, independent of the mass of the object. Now, a very interesting question arises. You have one watermelon in your hand and a small, tennis ball in your one hand. That yellow ball, tennis ball in your other hand. You just let it fall. You haven't provided any force. You just let those ball fall at the same time. Okay, a huge watermelon. Let's draw a watermelon. Okay, a huge watermelon and a tennis ball. I hope this ball is visible to you. Both are released at the same time. Which object will reach the ground first? Okay. Watermelon has mass of, let's suppose this is a heavy watermelon of mass 2 kg. This ball has mass around 40 grams. Okay. Both are released at same time. Which will hit the ground first? What will be the answer according to you? And the final answer is, the correct answer is, both will reach the ground at the same time. And why it is so? It is so because the gravitational acceleration is independent of the mass of the object. It depends on the mass of the earth. Okay. The gravitational acceleration is independent of the mass of the object. So you have a watermelon or a iron ball or a normal tennis ball. All the object will fall at the same time if they are released from the same height, because it is independent of the mass of the object. Is it clear, class? Okay. Where capital M, G become G capital M divided by T. Okay. D square, where capital M is the mass of the earth, D is the distance between earth's surface and the object. Let an object be on or near the surface of the earth. The distance D will be equal to the R. If any object is placed on the surface of the earth, then the distance D will become the radius of the earth. The formula of G will become capital G capital M divided by R square. Okay. Thus, for the object on the near of the surface of the earth, small g will become capital G M divided by R square. And we know that earth is not a perfect sphere. Earth is not a perfect sphere. Its shape is something like that, a flat sphere, where the radius of earth is maximum at equator and minimum at the poles. This is the exact shape of our earth. Okay, it is like flat sphere, not perfect sphere, where the radius of earth is maximum towards equator and minimum towards pole. As the radius of earth increases from pole to earth, the value of g become greater at the pole than at the equator. Okay, this is the shape of our earth. So radius is maximum towards the equator and minimum towards the poles. And according to this formula, the value of small g is capital G M divided by R square. So as radius increases, the value of g decreases, and R decreases, the value of g increases. So it means the value of g, gravitational acceleration, is higher in poles in comparison to equator. So the value of g become greater at poles than the equator. Maximum value at poles. Clear? For most calculation, we can take g to be more or less constant on or near the earth. For the calculation, we will take value of g constant on the all over the surface of the earth. Okay, but from object far from earth, the acceleration due to gravitational force. So we want to try to calculate the value of g. Let's calculate the value of g. Okay, g formula is ball g capital M divided by r square. We know the value of capital G. We know the mass of earth, which is 6 into 10 raised to the power 24, and the radius of 6,400 kilometers, or 6.4 into 10 raised to the power 6 meter. Put all these values in this equation, okay, and try to find out the value of small g. Okay, so we are doing the calculation, and we find out that the value of small g is 9.8 meter per second square, and we will assume that in on all the surface of the earth the value of g is 9.8 meter per second. But for calculation's sake, to make calculation easy, we will sometimes take the value of g as 10 meter per second square. But actual value of gravitational acceleration is 9.8 meter per second square. Clear? Okay, now motion of object under the influence of the gravitational force of the earth. So we have completed the part pre-fall, where we have seen that any object can fall under the influence of the gravity has a acceleration, and that acceleration is gravitational acceleration, and the value of gravitational acceleration is 9.8 meter per second square. Now we are trying to understand the motion of object under the influence of earth gravitational force, and we know that under the influence of earth gravitational force, most of the object do circular motion or fall on the surface of the earth. And to understand it, we will take a sheet of paper and a stone. Okay, a stone and a sheet of paper and stone are dropped from a building. Hmm. On the earth, okay, from the same height h. Let assume that there is no air resistance, no particle around, no air is flowing. Which of the object will reach the ground first? And you know that the value of gravitational acceleration is independent of the mass of the object. So you know that both of the object will reach the ground simultaneously or at the same time. Okay. We see that the paper reaches the ground. If we are doing this experiment in reality, then we will see that the paper will reach the ground little later because of the air resistance. Otherwise, both will reach the ground simultaneously. If there is no air resistance, nothing else there, okay, then both of the object will reach the ground at the same time. Okay, what is air resistance? This is the piece of our paper. When this paper is falling downwards, air molecule will try to stop the motion of this paper to fall on the ground, and it will resist and give it a upward motion, which is known as air resistance. The air often resists due to friction of the motion of the falling object. Okay, air offers a resistance Due to the friction of a motion, any object which is falling downward, then there is a friction generated between air particles and this motion. An air particle will resist this motion, known as air resistance. The resistance offered by the air to the paper is more than the resistance offered to the stone. If stone and paper both are falling at the same time, because the surface area of paper is large and the weight of paper is very less compared to stone, the paper will have to face more air resistance than compared to stone. If we do the experiment in a glass jar from which air has been sucked out, okay, let's suppose everything is miniature now. This is a very big glass jar, and there is a small piece of paper and small stone, and both are released simultaneously. Both will reach the ground at the same time simultaneously because of the free fall. Because both of the object will experience free fall. And why this is happening? This is happening because the gravitational acceleration is independent of mass. Is independent of mass. This means that all object, hollow, solid, okay, big, small, every object should fall at the same rate. According to a story, Galileo, a scientist, dropped different objects from the top of the Leaning Tower of Pisa in Italy to prove the same. Galileo, a scientist, dropped three different objects from the top of the Leaning Tower of Pisa, which is present in Italy, to prove this equation that all the objects will fall the ground at the same time. Now let's understand some more uh, theories related to gravitational acceleration. So in this we know the three equation of motion. Three equation of motion is V equals to U plus AT, S equals to UT plus half AT square, and third is V square equal to U square plus 2AS. Okay, if any object is moving upwards and gravity is pulling it downwards, okay, motion moving upward, and this is the direction of gravitational force F gravity, okay, then we will take acceleration in this case as negative g, because the object is moving against the gravitational force. If you are throwing any object upward direction, then the force of gravitational is downward, but the motion is upward. That means the acceleration is negative acceleration. And if any object is moving in the influence of gravity and its motion is also in downward direction, so in this case you will take acceleration as gravitational acceleration. You have to memorize the sign convention, otherwise your calculation will not be correct. Okay. Opposite to gravitational direction, negative. In the direction of gravitational acceleration, positive. That's it. So फिर upward case, when any object is thrown upward, acceleration is negative gravitational acceleration, and in downward case, acceleration is equals to gravitational acceleration. All these three equation of motion will get changed. V will be equal to U minus GT. S is equals to UT minus half GT square, and V square will be equal to U square minus 2GS. And in this case, V will be equal to U plus GT, S is equal to UT plus half GT square, and V square will be equal to U square plus 2GS. Okay, clear class? So I hope these three equations are clear to you for upward direction and for downward direction. So in today's class, we have learned about gravitational acceleration and free fall. When an object is falling under the influence of gravitational force, then that object is said to be in gravitational, is said to be doing free fall, and the force which is responsible for free falling is gravitational force. Okay, when any object is falling under the influence of gravity, then that object has acceleration. And because that object has acceleration, it means that object's velocity is changing continuously. Okay. And that acceleration is known as gravitational acceleration. We derive the formula of gravitational acceleration, which is small g equals to capital G m divided by r square. This formula is independent of mass of the object. It means that different object of different masses, if are placed on a same height and released from the same height, then all the object will reach earth simultaneously, because the value of gravitational acceleration is independent of mass of the object. Galileo, a scientist, tried to prove the same by dropping different object from the Leaning Tower of Pisa building. Then we have learned about equation of motion, that if any object is thrown upwards, then its motion is in upward direction, but the force of attraction is in downward direction. So the value of acceleration is negative g, which is negative 9.8 meter per second square. And if an object is going downward in the direction of gravitational acceleration, then the value of acceleration will be g only, positive g. And all three equations of motion will convert like this. So I hope today's class is clear to you. Now we will meet in next class. Thank you so much.